Hello, this is the first video in the SISEN demonstration series. In this video, we are going to demonstrate traffic observation and packet capture during normal SISEN operation. The idea is we will create some kind of benchmark. We will save those capture files for comparison later with the attack captures. So we're not going to introduce attack in this video, but we will show later how we can compare normal traffic with the traffic once the attacks are happening. So I will use, it's the same workflow and process for all the different scenarios. I wanted to use 6-low-pan industrial IoT simply because it exposes several different useful capture points within one topology. They include the low power wireless side, the 6-low-pan, the IPv6 path, the border path, the MQTT relay, and the dashboard. So there's a lot of different points where we can capture the traffic. And obviously all captures activity shown are limited to the control SISEN laboratory environment. So I'm going to open terminal again. And I'm going to start the 6-low-pan scenario with 4 industrial nodes, and I'm going to run it on an open access point. And we request capture guidance. So I'm going to go to SISEN again. So it's on desktop, SISEN, and as I said, just run the environment every time. So the first thing that we're going to do is we're going to launch the application. So launch SISEN, and using the scenario 6-low-pan and the access point open, and with 4 nodes and with capture hints. It's asking me for a password, and once we put the password, we have it running, and you can open a browser just to verify that it's running fine. You give it a second, and you can see now everything is connected. Now, what we're going to do is, as we said, the scenario, we chose the 6-low-pan, access point open, node 4, capture hints, and so on. Now we're going to show what we can do by capturing the traffic in a normal baseline. We want to capture the normal dashboard baseline. You can look here and you can see the normal dashboard baseline. So the values are updated continuously. They usually remain within the expected range for those industrial assets that we have. The important characteristics are which asset we're looking for. So we have different assets here. We have temperature for the 4 different locations. We have gas leak in 2 of them, humidity in 2, pressure, machine overheat, occupancy, emergency stop if it's pressed, and air quality in 2 others. So what we're going to do now, we're going to try to identify what are the interfaces that this scenario is basically using. So I'm going to keep this open. I'm going to open a new terminal, and I'm going to type sudo IP net namespaces ns list. Basically, namespaces are virtual network environments that we have created by using that environment. These were created by the 6-low-pan environment. It will ask me for my password, and you can see that there is 1 node here, 2 nodes here, and a border and an ID. So these are the different rooms that are available. For example, here you can see there's a border gateway, and there's also another node with an ID 0. So that's the 4 nodes. So now we are going to look at the interfaces inside those namespaces, because each namespace has different devices as well. So here in this namespace, we have different sensors. That's the border gateway, and that's the 6-low-pan device. So let's look at the different IP addresses in those namespaces. So we look at the interfaces and addresses inside every active namespace. So sudo IP dash all execute IP brief address. In all IP namespaces, I want to see the IP addresses. Oh, all right. So what we did now, we just run a command inside every active space. So inside every active space, which is the network namespace, we executed IP brief address. And that will display the interface's name. So you have in node 2, we have a border gateway and MQTT. In the border router, we have the 6LoWPAN and the border gateway as well. And we have in the nodes, we have the LoWPAN and the WPAN. So WPAN is basically the i802.15.4 side. The LoWPAN 0 is the Linux 6LoWPAN interface. The border IP is basically represents the border router forwarding path where it's forwarded to the internet or to the dashboard. The node 2 border represents the traffic entering the forwarding nodes, and node 2 MQTT is basically traffic leaving towards the MQTT relay. You'll find there's a lot of different interfaces. All of these interfaces are basically how the data travel from the sensor all the way through the border gateway to get to the MQTT and then represented on the dashboard. Right. Now, if you want to inspect, for example, a specific namespace, you can actually look at it specifically. So we can, for example, let's say you want to inspect node 1 or node 2 here, or node 1, it doesn't really matter. IP brief address. So basically what we are doing again, in that namespace, we are executing node 1 IP brief address. And that gives us specifically the information for node 1, which is this basically. Right. Now, what we need to do now, we can also inspect interfaces on the host itself. So if I type IP, so the IP net namespaces was inspecting the interfaces inside the namespaces. You can also inspect the interfaces outside the namespaces on the host itself. So if I type IP brief address, that will give me the interfaces that I have. So I have WLAN 0, which is basically the wireless access point, in this case, open access point. We have obviously the network communication for my PC and localhost. And we also have the MQTT, which is the dashboard, the dashboard is referring to. So the host view is useful for finding dashboard tracing traffic. This is it. Because it allows you to see what's the bridges, what's the loopback, or other interfaces that are not part of the scenario namespace. In any case, so we will begin capturing traffic from the low power wireless side of node 1. And you can see those here. So here we have all the different information about how to capture traffic for 6LoWPAN. So the interface that we're looking at for 802.1.5.4 side traffic is WPAN1. And if you look here, you will find that WPAN1 is the first one here. You can copy it all the time. I'm going to type it the first time and explain what it is, and then we can copy it and paste it in every time. So let's try with the first one. We're going to use WPAN1. So I'm going to use TCP dump. So I'm going to do sudo IP for the namespace itself, network namespace, execute node 1, and then TCP dump minus I, the interface, WPAN1, and then minus N. So the interface is WPAN1 minus N, which basically tell us to prevent an address and port name resolution. It's important. And then minus W. Minus W is basically increases the amount of packet details, so you can read more. We can see more packet. Minus VV, which is the verbose mode. It shows us more information about the packets. And then minus S 0, which is capture the complete packet rather than truncating it. And then minus Z, capital Z, and that's the, you keep that as user. So whatever the user is for you, it's fine. And then minus W, the name of the file where you want to write the file. Now, we have already in SISEN an empty folder called captures. You don't need to use it, but it's a good idea to have all the captures for your activities in one place. And for that reason, I'll just type captures, which you can see the folder already exists. And then after captures, I can name it whatever you want. So for example, I can name it 6LoWPAN node 1 WPAN.pcap. So I know which exact interfaces and traffic side I'm capturing. And now I will press enter. And I think that should be it. Right. Now we can allow the capture to happen for a while the scenario continue publishing those normal telemetry, and you can stop it later on when we have enough traffic. You can also actually let me open a new terminal, or let me put it here. I can show all the different mosquito messages that are happening, all the different where is it? Here it is. So I'm going to just put everything that we are subscribed to here, so we can see them as well on our interface. These are the things that are reported to the dashboard anyway, but we can keep them running for a while. Now, while we're doing this, so that to speed up and to shorten the video as well, I'm going to open another terminal, and this time I'm going to capture the LoWPAN 0 in the same namespace. And this interface, as we said, is about the traffic between the 6LoWPAN and the border gateway. And if you think about it, it's the Linux interface. So this is how the Linux is forwarding your messages to other interfaces and so on. So let's try to copy paste it straight away rather than doing it here. So you're going to capture the LoWPAN 0, and I'm doing them in the order. So we'll capture the traffic of LoWPAN 0 as well. And at the same time, we will capture. So we use the TCP dump basically to capture LoWPAN 0, and but so the only thing that changed here is the LoWPAN 0, the interface, and the name of the file basically. And that will also allow us to capture the interface. You can capture one by one. It doesn't really matter. I'm just capturing all of them together. And I'm going to create a new terminal. And I'm going to capture the router border path. So the border IP specifically. So I'm going to go to the border IP here, which is this one. And I'm going to capture it. So it's listening on border IP. So it's executed the namespace again. TCP dump again. The only thing that changed in this case is the name of the interface and the file name that we're storing to. The border router, as we said, connects the constrained low-power networks, the 6LoWPAN, to the wider IPv6 forwarding path so that it can forward it to the other traffic. And this capture helps us show basically the telemetry leaving the 6LoWPAN side and move towards the relay and dashboard environment and TCP and HTTP and so on. I can also capture the dashboard facing MQTT path. Let me just start stopping one by one, otherwise they will become too much. So Control C. Oh, we don't have anything running here. Control C. This one we just started it now. So we're going to capture the facing MQTT path now. So we're going to capture the traffic that reaches the dashboard facing. For this capture, we're going to use any interface because the objective is to observe all host sites traffic. Anything that is coming from all sensors we will need to capture it. So you can use any as an interface rather than a particular node. So we will use it's somewhere here. Here it is. Now, the only thing that changes here, in addition to the port name, so again, port name is everything. And we didn't use the namespaces because now we are on the dashboard. So now we are not on the namespaces of the node. We are on the HTTP side of the network. That's why there's no dashboard. There's no namespaces. We're capturing everything that is coming on from all interfaces we save it as 6LoWPAN MQTT dashboard, and MQTT operates on port 1883. I'll put my password again. And you can ignore the promiscuous mode, and it's now capturing traffic. You can see there's a lot of traffic coming to it. So this capture is intentionally broader than the namespaces because we want to capture everything. But if you want to capture specifically a protocol level, then you can use the MQTT telemetry directory, which we already did by running the mosquito here. So you can stop them one after the other. So we stop this, you can stop this, and you can stop the border IP running as well. Let me close all of them. So what are we looking for now? So we're looking for a lot of different things in our environment. So we're looking for the assets, the node identifiers, the telemetry fields, the values, and everything else. We're also looking at the sender and the receiver information and so on. But what I want to say first is all of those files are now stored in capture folder. So if I type ls captures, that will show me that I have 1, 2, 3, 4 different pcap files. And you can open those files if you want to see them in more details using Wireshark. So I'm going to use Wireshark and I will open them one after the other. So 6LoWPAN captures, 6LoWPAN border IP.pcap. That's the first file. Well, actually, let's start with the one that is for the MQTT capture. So MQTT dashboard. And if you open it, and you'll find a lot of different traffic, but specifically you'll find the MQTT and TCP traffic because this is the dashboard facing. But let's filter specifically MQTT. And you can see now that there's a lot of different comments specifically about the publishing, whether it disconnect and then it publish, whenever it goes back again, it publish, and so on. For any of them, you can inspect different things. So I'm going to inspect, for example, the source and destination. That's the source and destination, which is 127.0.0.1. Both of them are coming from the same planes, of course, but you can look at the TCP ports. So you can look here and see that they are coming from source to destination, but to different port, because each one of them is running on a different port. We can look at the MQ telemetry transport protocol messages, and we can look at the message payload. You can look at what it is. For example, here it's a temperature one, and you can look at the published packet. Specifically, these are published packets. These are the ones that matter because they will have payloads. You can even try to get a lot of information about, for example, how many times that sensor publishes, because this shows you, for example, each one, how many times it's publishing, the frequency of it publishing, how fast it is, and so on. And the payload, of course, contains all the values delivered. So these are the values here, and you can find them in the information here in a hexadecimal. Now, you can also look at different things. So we can narrow down the different information that we're looking for. So, for example, I can say I want to look for MQTT, but topic contains industrial 6-low-pan. So now I'm looking at all the different nodes, and this node 3 is basically publishing temperature, humidity, occupancy, air quality, and temperature. You can see it's repeating. Or I can say I want to look for something that is capturing temperature only. Like I can specify temperature. I can specify the specific node that I want to capture. I want to basically analyze. And this filter is allow you to basically limit the display so that you don't see anything that is not relevant for what you're looking for. You can also inspect by searching for specific terms, for example, temperature. And this is important, specifically later on when we're doing attacks and we want to see how the temperature is changing values and so on. Let's open, for example, low pan 0 and see what are the other things that you can see. So I'm going to open 6 low pan and node 1 and low pan. Now in here, you can see that Linux exposed traffic that is UDP-v6 specifically, which is the IPv6 source and destination addresses. And you will also find evidence related to UDP source and destination port. Both are quite important. So we can look for IPv6 traffic. So we can filter by IPv6 traffic. You can also filter by UDP traffic. And you can also, for example, the important point in this capture is the relation between the low power nodes and the IPv6 and UDP packet. And of course, for each node, you can find all the information you need, the payloads, the source, the destination, the port values, and so on. And finally, I'm going to look quickly at WPAN1. So I'm going to open node 1 again, but this time I'm going to open WPAN pickup. Now in WPAN we can only we can filter straight away WPAN traffic. That's the 6 low pan traffic that we are looking for. So WPAN, and this is the 6 low pan traffic. And when you're decoding 6 low pan traffic, it's usually important to check a few things. It's usually important to check the source and destination information, the frame type, the pan related information, the 6 low pan related information, which are here. And the relationship, for example, if you want to identify the source and destination of the IPv6, is basically to try to identify it and see how it relates with the IP addresses of the sensor themselves. The purpose is not really to decode every field. The purpose is basically to identify the communication layer represented by this interface and compare it with the more processed view of flow band 0. Now, that's quite a lot of information that you can get, and we can basically see that there's so many things that we need to inspect, specifically if you're trying to create a baseline. But I think when you're running a scenario or when you're running an experiment, it's important to measure the baseline, record the baseline, and then conduct the attacks in this controlled environment, and then see the differences. The differences is what matters, because then you can see what's happening and how they affect the safety and how they create hazard on the scenarios that you are running. In the next video, we'll introduce the attack over workflow and explain how these control attacks are selected and executed. Thank you.